guys, welcome back to my YouTube channel. So today we are going to solve day 19 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So we are going to solve problem number 241, different ways to add parentheses. Okay, so let's read the problem statement first. So we have given a string expression of numbers and operators. Right, we have to return all possible results from computing all the different possible ways to group members and operators. Okay, you may return the answer in any order. The test cases are generated such that the output value fits in a 32-bit integer and the number of different test results doesn't exceed 10 to the 4. Okay, so now let's understand this with an example. Okay, what we need to do actually here. So here this is the one expression given to us, right? So here I can do multiple things. First, this is number, this is my operator, right? Number, operator, number. Okay, so if I just want to give the indexing here 0 1 2 3 4. Okay, so I see that at index number 1 we have one operator and at index number 3 we have one operator. So let's do one thing now. Let's split this string over my index number 1. Okay, so let's split it like this. Okay, so what is the result that I'm going to get? 2, and here I split the string by like this. Okay, so here I will get my output as 2. Okay, this is one of my output, right? Or I can split my string over index number 3. Okay, so if I do that, so this is how I'm going to split it, right? So then what is the result that I'm going to get? I'm going to get a result as 0, and this is one of my output, right? So this is what we need to do here. So that is why we are getting these two outputs, right? So we can return the result in any order, right? This is given to us. We have to just return all the possible results from computing all the different possible ways to group of numbers and operators. That's it. Okay, so I hope that you guys are clear with example number 1. Now let's understand example number 2 here. Okay, so here this is my expression. Okay, 2 into 3 minus 4 into 5. Okay, so see here first in this expression number 1, right? Example number 1, this expression. So there are multiple ways to get the result, right? So every time I'm going to do the backtracking, right? First I am checking on this case, then after that I'm checking on this case. There are multiple cases. Okay, so I need to do the backtracking and again and again. So definitely I'm moving towards the recursion here. Okay, so this example number 2. Okay, so how I'm going to solve it? So first, if I just want to give the indexing here, so at index number 0 we have a number, at index number 1 we have operator, this is index 2, this is index 3, this is index number 4, this is index number 5, and this is index number 6. Okay, so we have operators at this index 1, index 3 and index 5. Okay, and these are the multiple results that we are going to get, right? So now let's see how we are going to do this. Okay, so here these are the steps, okay, that how I'm going to solve this problem. So first I'm going to call this function, different ways to call, and in this function I'm going to pass my complete expression. Okay, so this complete expression I'm going to pass. Okay, so first I'm going to find this star at index number 1, right? At index 1 we are finding this. Okay, now I'm going to I'm just going to split this expression into two parts. So in the left part I'm just going to add this 2, okay, left part, and in the right part I'm going to add this expression 3 minus 4 into 5. Okay, so this is what I'm going to do. We have splits into 2 left and 3 minus 4 into 5 right. Okay, now we are going to call it recursively every time. So now let's recursively call this left side 2. So in the left side I see there is only just one number, so we are just going to return 2 because it is a single number. Okay, so from here I just return 2. Okay, then I am going to recursive call my right side. So again see this expression, different ways to compute. So initially I was passing complete expression, now I am just passing this expression because for the left side I get my answer 2. Now I'm just going to solve this expression 3 minus 4 minus 5. Okay, so just make a note of it. I'm solving this expression right now. I have already got the result for the left side. I'm solving right side. Okay, so here first I will see that this index is available at this index 1. Okay, so this is a new expression now, so just give the indexing to this new expression as well. 1 2 3 and 4, right? So I will find this minus at index 1. So again I'm going to split it in two parts. So in the left side I am adding 3 and in the right side I am adding 4 into 5. Okay, now after that again I'm going to do the recursive call. Okay, so now in the recursive call I'm just passing the left side. So here I'm just going to return 3 because it's a single number. Okay, so this is my expression, right? 3 minus 4 into 5. So for the left side I will get just 3. Okay, and now again I'm going to call recursively for the right side. So in my right side this time I'm going to pass 4 into 5. Okay, so I will find this star at index 1. So again give the indexing here 0 1 2. Okay, so I will find this star at index number 1. So again I have to split into two parts, so left and right. So see, different ways to compute. Left side I pass, I will just get 4 because it's a single number. Then right side I'm just going to pass 5 and I will get return 5 because it's a single number. Then after that I'm just going to combine the results, because from here and here I'm just going to get one number now. So I can simply add this left and right. I can simply do multiplication here because the operator is multiplication here. So I will just combine the result for 4 into 5. So this one result I am going to combine. So I will get 20. Okay, so I get 20 here from this part. From this part I get 20. Now after that I backtrack to this recursive call. Okay, this recursive call in which I am passing complete string. So for this I get 20. Okay, now this left side is 3. Okay, so 3 and 20, which is the operator inside between them, a minus. So 3 minus 20 minus 17. So I will get minus 17 here. Okay, then after that again I am going to do the backtracking. So I reach from here, I go to this one. So for this complete expression I get output as minus 17 and here the output is 2. Okay, so 2 into minus 17 I will get minus 34. So minus 34 is going to be my one of answer. Okay, so I hope that you guys are clear how I'm getting minus 34. Alright, so now I have solved this, right? Now see here, if you just backtrack, you see that here in this, okay, let me highlight this. In this I was doing a break here at index 1, but we can also split the string like this here from star itself, right? Why I'm doing this one? So we are doing the backtracking here. Okay, so I get this output. Now after that again I'm going to check in this recursive call. Okay, I can do this now. Instead of breaking here with minus, I can do this. I can break it like this, right? This is also one of the possible case. Okay, so here this is going to be my expression. So I have I got one result minus 34. Okay, this is one result. Now here this is my left and right. So now for left we are only going to get 2 here. So this is we have already solved, right? And now we are going to compute right. So here we are going to split star, which is available at index 5. Okay, so here just give indexing 0 1 2 3. Okay, this is giving overall index, right? So you can, or you can simply say, so here it is 0 1 2 3 4 and 5. It is saying like this. You can ignore this index. So just understand that we are going to split based on this star now. Okay, so in the left side I am using 3 minus 4. Okay, so this is what I have explained. Take this as left now and this is right. Okay, so here left is this, right is this. Now we have to compute the left of the right part here first. Okay, so here 3 minus 4 is going to give me minus 1. So from here I am going to return minus 1, and the right part we have 5, so we will get 5 only. So here we are just going to compute the result of left and right. So I will get minus 5. Then I'm just going to combine this minus 5 with the left side. So minus 5 into 2 I will get minus 10. So this is going to be my one other output, minus 10. Okay, then we have seen two cases. Okay, so here we have split like this, 2 then 3 minus 4 into 5. Okay, so first here this is multiplication. Okay, so we get this result. So where we are just splitting it like this, left and then this left and this right. Okay, this is the result that we get. Okay, then we get this result. We again single left, then this was complete left, then I take this left and right. Okay, so we get these two results. Now we will see how we will get next 14. Okay, so here this is expression, so here I split it at this point position. Okay, split at -1. So left is this one, right is this one. Compute left, we will get 6, and compute right, we will get 20. Now combine left and right, so in between the operator is minus, so I will get -14 here. This done. Then after that there are other cases. So in this I am just going to take complete this as left and this as right. So here from right I will just get 5. Now compute left, 2 into 3 minus 4. Okay, so here into 2 into 3 minus 4, so I will get compute left of the left part and right of right part. I will get this result. Okay, then I have to combine, I will get -2. Then we have to just combine left and right, so here I will get -10. Same way here, if we split at this index number 5, then this is left and this is right. So here if you see, I have split like this 2 and 3 minus 4. Okay, 2 and 3 minus 4 different. So here I am splitting like this 2 into 3 and then 4. Here I was splitting like this 2 and 3 minus 4. Okay, one by one. So in this part I will get my output as 10. Okay, so just go over all these expressions. Okay, how I'm going to solve this. So simple way, I'm going to write the same code. Okay, whatever I explained here. So okay, little bit tricky, but yeah, it's good to understand all these concepts, right? So there may be some expressions repetitive. Okay, so like this you can see. So here see, 4 into 5 is nothing but, here I will find this star at, split into this 4 into 5. So 4 into 5 is nothing but 20. Okay, so I have calculated this 4 into 5 here. Okay, just note this, calculated here one time. Okay, then here if you see in this part also I am computing right again. Okay, 4 into 5, 20. Okay, calculating here as well time. So why do I need to calculate it multiple times? Okay, why I am going to solve this expression again and again? So I can simply store the result of this expression somewhere, right? I can do one thing, right? 4 into 5, I know it is always 20. So for this particular expression I will store the result in my memoization array, so that I don't need to repeat the steps. Okay, so I will create one memoization array. In that memoization array I'm just going to pass this expression. Okay, and for this expression I'm just going to save my output. Okay, so this is one thing that I want to clear here. Okay, so now let's move to the coding part. Okay, so here first we have to just create one map to store the computed results for sub expressions. So here let's do one thing, write it here, private map string, and here list of integer, and let's give a name as memo, and here new hash map. Okay, this is done. And now after that, inside this we have to check if the result for this expression is already computed. That is why I'm going to store memoization in the result in memoization. Then we have to just simply return that. Okay, so here I'm just going to write if my memo, okay, dot contains key. Okay, key is going to be nothing but my expression. Okay, string expression. So if it contains that particular key, so here I'm just going to write expression. Okay, if I have already got the result for that particular expression which I'm going to solve, then in that case we have to just return memo dot get the value of that particular expression. That's it, easy. I hope that you guys are clear till now. So this is nothing but my base case. Okay, now after that what we need to do, so here let's create one list of integer result is equal to new array list. Okay, and now after that we have to iterate through the expressions and look for the operators. Okay, so here just run one simple loop for int I is equal to 0, and my expression is every time changing. Okay, so I can calculate the length like this, expression dot length, whatever my new expression, just calculate the length of that one. That is why I didn't create one variable to save the expression length initially. Okay, I plus plus, I'm going to call this different ways to compute again and again. Okay, so here inside this, now simple things that we are going to do. First, let's check the character. So if that character is operator, then we need to do few things, right? So here I'm just going to check. Let's first create one char character is equal to expression dot char at this particular index. And now after that, here I am just going to check if the current character is an operator, we have to split the expression. So here if character is equal to plus, or if my character is equal to minus, or if my character is equal to multiplication. Okay, so only these characters are given. Okay, these operators are given to us, right? So here inside this I have to recursively calculate the results for the left and right sub expressions. So how I'm going to do that? So here list of integer left, and here just going to call this different ways to compute method. Okay, just copy this, and in this I am just going to pass one substring. Okay, so expression dot substring starting from index 0 and until I. Okay, I is going to be one operator only, right? This I. So here this is exclusive index. Okay, so here first I found this operator at this one. So 0 to I, 0 to 1, 0 to 2. Okay, this is at 2 now. So simply means that I am taking this. This is 1, sorry. This is 1. So it simply means I am taking this 0 only. Okay, this is exclusive. This you guys already know, right? And now after that, again we have calculated left, and in the right side I have to pass one expression. So in the left side I am passing this. Where is 2? So in the left side I am passing this 2, and in the left side right hand side I am going to pass this complete. Okay, so here just going to solve first for 2. So for 2 I am going to solve. So this is done. This part is going to done. Then after that, after solving this, I will move to the expression at the right side. So in the right side, what is the expression that I am going to pass? Just copy this. One second. Copy this, paste it here, and now this is going to be my right. And in the right side I am going to pass the expression which is starting from index I plus 1, complete expression. I am going to pass this complete expression, 3 minus 4 into 5. Okay, then I am going to call this, okay, 3 minus 4 into 5. Then I am going to solve that 3 minus 4 into 5. Okay, one by one. So recursively it will call okay, everything. Then once I get any value from this left and right, then after that what I need to do? So I will get some value from left and right. Okay, so we have to just combine the results from left and right sub expressions using the operator. So here I'm just going to write for int L left, for int R in right. Okay, and inside this I am just going to check if my character is equal to plus, then I have to add that into my result dot add. Here just write L plus R. Okay, and same way here else if character is equal to minus. Okay, if the character is minus, then what we need to do? Then result dot add. Here write L minus R, and here else if the character is equal to multiplication. Okay, in that case what I need to do? So in that case we have to just add result dot add L into R. Okay, so this is what we need to do here. Okay, this is done. So this is where this loop ends. Okay, 1 2 3, and after that here for this particular right, and then here this ends, this complete. Okay, so every time whenever I'm going to get one result, so here I'm just going to write one base case. If the expression contains only a number, okay, then in that case we have to just return that particular number now. So here simply means that in that case my result will be empty only. Okay, because 0 and expression should be less than 1. Okay, but I will not find these characters. Okay, plus operators, right? So in that case my result will be empty every time. Okay, every time I'm creating one empty array list here. Okay, so here just I'm going to write if base case, if a result is empty. Okay, so here just I'm going to add result dot add here integer dot parse int, and here I'm just going to pass that expression. Okay, just converted that expression, right? This 2 was expression, okay, string, so I just convert that into single number. I will get 2. So this is what I'm doing here. Okay, this is done. Then we have to just 2 lines are pending. That's it. Then we are done. So here one more thing. Now we have to store the computed result in the memo map. Okay, so here I'm just going to write memo dot map memo dot put. Okay, and key is going to be my expression and my value is going to be result. Okay, this is done. And then just return result. Okay, alright. Now let's run the solution and see if there are any problems with our code. So yes, here CH should not be capital. This is one issue. Let's fix that and run the program again. So all the test cases has been accepted, and here see I'm getting result like this: minus 34, minus 10, minus 14, minus 10 and 10. Okay, so minus 34, minus 10, minus 14, minus 10 and 10. Okay, so in this order I'm getting the results. Okay, now let's submit it. So see, our solution is accepted, right? And it beats around 99% of users, right? So I hope that you guys are able to understand today's problem. If you guys still have any questions, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.